Hello and welcome back to the lab. Today we are going to be talking about relays, and in a previous video you saw me salvage this from an old UPS circuit board, and then it occurred to me, why not make a video explaining how we use this and show you how to connect one of these. So these are what are known as relays, and by definition a relay is just a switch. It's a switch that is operated by electricity, and it opens and closes a circuit. So on one side of a relay you will be having a control signal, and on the other side of this relay you are going to be having the signal that you want to switch. So either a high voltage or a high current. It will depend with the application. Well, today we are going to be looking at this and discuss on how you use one. We can also look at an example of a circuit and also do an illustration. We are also going to be looking at how one of these looks inside. Well, let's get started. From definition, we have said that a relay is just a switch that is operated by electricity. You will have a relay like this, and from one side you are going to have your control signal there, and on the other side you are going to have your switch. So this side you are going to be having the control signal, and this control signal can be any voltage from 5 volts up to 24 volts depending on the relays specifications. Now, having known what a relay is, let's look at how it works. And in order for us to understand well how a relay works, we need to know what are the elements in a relay. So a relay will consist of 3 elements. One of these elements will be your electromagnet, the other one will be a lever, and the third one will be your contacts. So if we open up one of these relays, so these are the components that you will find inside this. So this element here will be your electromagnet. The second element will be your lever, and the third element will be your contact. Sometimes the lever might be tied to one of the contacts, but let's go through them and see what each one of these does. Now, the contacts work exactly the same way as a mechanical switch work. The incoming wire will be connected to one contact, we can call it A, and the outgoing wire will be connected to the other contact, we can call it B. So the contacts will either connect to allow current to flow from point A to point B, or will disconnect to break that flow of current, therefore acting as a switch, just the same way as a mechanical switch does. What is the work of the electromagnet? Now, for the electromagnet, upon applying control signal at this point XY, this coil will get energized, and there is a piece of metal rod inside here that gets magnetized, and it pulls this lever, and this lever in turn pushes one of these contacts, and they make a connection at this point, and therefore closing the circuit, allowing the current to flow from A to point B. If we remove the control signal, our magnet here will get demagnetized. It will release this lever, and therefore this contact will be broken, therefore breaking the connection between A and B, and thus cutting the flow of current. So that's very simple. So now, how does a relay look inside? So this is how a relay looks. So you have your copper coil there, and then I don't know whether you can see there is a metal rod there. So this is the lever, but in this case the lever is tied to one of the contacts. So this one, upon applying a voltage at this point, so these two pins, this magnet will pull this lever, and then it will make a connection there. So you can see those contacts. Now let's apply a signal here and see how this works. So actually this relay has two connections. When it is off, one circuit is on, and when it is on, it breaks one circuit and connects the other one. So as you can see, we have 3 contacts. So let's see how it works when we apply some current. So the leads for the coil are the 1, 2, these ones. So if we apply some 12 volts, so whenever you hear a sound when the relays are turning on or switching on, it's because of these contacts, actually the magnet pulling the lever and therefore making that contact. So if we apply this here, just watch. See how we make a contact there, and that's how it works. So now, how do you connect a relay in a circuit? So assuming we have a motor that we want to control, or rather to switch on and off using a relay. So this is our motor here. Now we need to use a relay to switch it on. So this is our relay. So that is our coil there, and then here we have a switch. So that is our relay. Then we need power source for our motor here. So one lead or one wire will connect there, then the other one will go there, and then like that. So when we apply the control signal at this point, so we have, so this is where we apply our control signal. So let's dedicate one pin to be our positive and the other one to be our negative. So something like that. So if we apply a voltage here, so this electromagnet here will become energized, and it will pull this lever, and then we are going to make a connection here. So if we make a connection here, then our current will be able to flow through the circuit and our motor will be on. If we remove this signal, then the reverse happens. We break this connection, our motor goes off. Let's demonstrate that. So I have two sources of, so this is our motor here. I have two sources of power. I have this one, so this is 12 volts, and we have another source here, so this is also 12 volts. So I need to do this connection. So our motor there and our relay here. So let's do a quick connection. So for this relay, so the coil side is this one, and the contacts are this. So one of these, so we have two contacts, I mean two pairs of contacts, so this one and this one. So we are just going to use one. So the red wire is our positive, the black one our negative. So just like that, one lead of our motor will go here, the other one directly to the source. So this is the power source for our motor or our fan. If I connect this one here, the fan won't go on. So because we need to supply the control signal. So let me switch on the control signal. If I apply the control signal, our fan should just turn on. So also listen for the click. Listen for the click. Hear the click, and then the fan is on. So if I remove the control signal, our fan goes off. So this is the basic connection for using a relay. But in real circuits, this is a recipe for disaster. The reason why I'm saying that this is a recipe for disaster is that we need to understand that a relay is an inductive load. And with an inductive load, whenever we interrupt the supply of current to the load, so this side of the coil is the inductive load for the relay. So whenever we interrupt the supply of current to this one will cause a very huge voltage surge. So what we mean with that is that upon switching this coil off, this thing turns into a generator. So whenever you are applying a voltage to this coil, the magnetic flux increases, and upon switching off the current, that magnetic flux will drop, and it will do so very fast. And by doing that, this coil will generate a voltage, and that voltage will be in the reverse polarity as to what we had applied earlier. So that means if we switch this coil off, so this side will turn to be our negative and this side will turn to be our positive. Now this voltage is very dangerous, and it can cause harm to the rest of the circuit. So we need a way of dissipating this energy. So what we do, we apply, or rather we use a diode. So we are going to use a diode here, and this diode should be in the reverse bias. So like that, so that whenever we apply the control signal, this diode will be in the reverse bias, and we are not going to cause a short. So we are still going to energize our coil. When we switch off the coil, so the voltage that will be generated here will be in this direction, and it will flow through this diode, therefore protecting the rest of the circuit. Now we can use an oscilloscope to monitor that and see how that spike happened, but I have a way of showing you how that happens. So I'll use an LED. So let me break that off. So I will use an LED, and just to monitor that voltage, and then I'll connect it in the reverse bias. So I'll connect it here. So then I need to use a resistor here. So we drop some of that current so that we don't burn our LED. So let me look for a resistor. Like a 1 kilo ohm resistor will be okay. So this is a 1K resistor connected here. So let me see whether the LED works. So you can don't know whether you can see the blue LED is on. So but now we need to connect this in the other way. So if I apply this voltage here, you can see our fan is on. But watch what happens if I turn this relay off. So this happens so fast. Watch the LED. See the LED blink. Maybe it can be better if I switch off the light. Now you see why we need to use a diode across these two terminals of our relay, so that we can dissipate that power that is generated when we switch off the coil. So whenever you are using a relay, remember to use this diode. So this diode is known as the flyback. The flyback diode, a very key part of this circuit. So the next point is how are relays rated. Now we have two ratings for any relays, and the first one will be your electromagnet rating, and the other one will be the ratings for your contacts. Like in this case, we can only apply up to 12 volts DC for our electromagnet or the coil side, in short. Going too much above this will be frying your coil. So the other one will be the ratings for the contacts. So like here we have 10 amperes at 250 volts AC, and the other one will be 15 amperes at 125 VAC. Well, that's how relays are rated. You just make sure you don't exceed the relays ratings, or otherwise you'll be creating some fireworks. Well, at this point I think I'm done. I'll see you in the next one. Remember to share, subscribe, and also you can leave a comment. Well, I'll see you next time.